Yeah, it should be streaming now. There's a video, I don't know why. Okay. All right, let's start. Great. Good afternoon, everyone. How are you doing? Great. So let's start. Before we start with textures and aliasing, a few words about that, I would like to discuss several very important and I think interesting for you points. So let's start with the assignment that I'm gonna introduce today. So you will have like exactly 3 weeks to complete it. The deadline is 25th of February, Monday, 2 p.m. before the lecture. So the reason why we decided to set the deadline like that is that otherwise everyone would be working on that and no one would show up on the lecture. So and then we will have a lecture 6th on Tuesday. We won't have a lab, and instead of the lab we will have the presentation of your assignments. You will just like show what you have done and so on. So to go to the details what the assignment is about. Yeah, some of you might have noticed that the deadline is updated here. We're gonna go back to 40 years and start something with something very, very simple. So anyone who doesn't know Pac-Man? Maybe I should zoom in a bit. Yeah. So to make long story short, you have to do 2D Pac-Man game. So anyone who is not familiar with the gameplay? Yeah, very good. So you will create 2D Pac-Man with like conventional gameplay, Pac-Man moving, collecting some collectibles, and there will be some ghosts. And gameplay will be as usual, like collect collectibles, avoid ghosts, and you just need to have one level, so no, like it's kind of a fundamental requirement, but if you want to have several levels with several difficulty, that's also up to you. It's just 10% of your grade, but if you do some of the extra work, you will get 5% extra. Very rewarding task because this will be a good fundament for the second assignment and also for the exam. Yeah, first of all, we need groups for that, like groups of 2 or 3 people. You have to register your group on this page. And so here is just an example, and you need to extend this table and write your username on the GitLab, your group name and repository where you provide the solution. So in order to do that, you have to edit this wiki. So yeah, this do you have experience with this Markdown? It's very simple. Like you can what you can do is for example, let's say copy the rows from kind of sample one and add it to this table and write something, let's say this, and you can then preview that, how it would look. Here you are, so we have new rows added, so we need to have all of you here registered kind of, and make sure that this allocation is up to date. So add your username, group name, and repository URL, and then we will know who is working with whom. So just like one point, can you edit whether you have permission to do that? So this is very important. Yeah, and it's very unlikely that Oh yeah, one last point about the assignment. Just make sure that you can access the repo. And are you able to see this this page? Can you check it now? So you were able, right? Yeah, that's great. Okay, yeah, because last year there were some problems with access. Great, let's switch back to the presentation then and discuss another important point. So 25th of February for the first assignment, and now more about the other stuff in the calendar. So our last lecture is planned for 8th of April, and the last lab is planned for 9th of April. Afterwards, as you have probably checked on the course description site, this week is off completely, the week before Easter, 16th. There is no lecture because it's a public holiday on Monday, and then we start again on 23rd of April. However, we need to agree on, like, it's not, there is no rush, we don't need to decide it right now, but I'll just provide you some options. Yeah, like assignment, oh yeah, one thing. As soon as we are done with the first assignment, we will introduce the second assignment immediately. And you will have like pretty much time, I guess, around 2 months to work on that. So it's pretty generous time frame for that. And yeah, 23rd of April, noon, 12 o'clock is the fixed deadline for submitting, like for completing your second assignment on the repo. But we need to agree on when we will have presentation of that assignment and the exam. So one thing I propose, like I have 3 options for you. Let's go one by one. Like one thing is having it the same day, right after the deadline, present it immediately, and then have the exam, because exam should be over the weekend. Like we will introduce it on Friday, you will have Friday, Saturday, Sunday, and the deadline will be Monday. So like, and have the exam in the same week, finishing on 29th of April. So in this case, it will be very intense, but if you want to really finish it as soon as possible and like just make this course done, this is one of the options. Another option can be having the presentation of the second assignment week after the submission, so that you will have some time to prepare your presentation and just go through the whole project you have worked for about 2 months. And then have the exam in that week, so this is the beginning of May. And another option can be like similar thing as the second one, but last year some people requested a week between the assignment presentation and the exam. I don't think that's really necessary, because it's not a written exam where you need to remember some theory and like really go through all the slides. It's more like learning by doing, and it's just based on your skills you have acquired throughout the whole labs and the course. So it's not something you have to just sit and prepare, because that process will be through during the exam. So, but it's up to you. If you want to have that 1 week break, this can be another option, like 23rd the deadline, then by the end of April presentation, and mid-May the exam. Yeah, and those aren't the only options, so you can give any idea if you think any other arrangement of those ones. So the deadline for assignment is fixed. This week is off, we can't do anything with that. So the materials will be finished this time, but we are flexible with the presentation and the exam. So like, any comments, which one do you prefer? Any idea? So we don't need to decide this right now, but I would like to have some feedback from you. Do you have an idea? Maybe some, like, maybe you have better proposals for the dates, and then I think later this week I will prepare a doodle where all of you could kind of mark and vote which options you prefer, and would be nice to have that decided maybe next week or latest week after that, because yeah, people need to plan ahead, and it's always good to know in advance. So like, just start thinking about this. If you have any ideas, any comments, which one, any preferences, and yeah. So no comments about this. Does it make any difference? Any of those?
I think the operating system exam is on the 15th of May, so I would probably prefer to have the graphics before.
Okay, so maybe the second one.
Yeah.
Does everyone have that operating systems course? So is it problem for like many people? Great. So yeah, maybe then the options 2. Yeah, that's why I'm presenting this, to get the feedback and know like what are your preferences. And one last thing about this is that I know from Christopher that some of you has bachelor's this semester that has deadline in this week, right? Is that true for any of you? Does anyone have like bachelor deadline in week 20? Because like one last thing that we don't really need to agree on right now, but also to have on mind that after the exam, after you finish your exam, we need a presentation for that too. So like this one, you submit your assignment and then you present that. The same for the exam. When you submit that, then you need to present. But for this one, you really need some time. It's not possible to have right after that, because we will ask you to prepare some videos, some like very like more professional presentation of your work. So it would be nice to have some time in between. And Christopher's proposal was to do that in week 21. But is it like too late for any of you, or too intense, or so when do you prefer to have also think about that? Depending on the exam date. So if we have the exam maybe from 3rd to 6th of May, then yeah, this week can be a good candidate for that. But again, like, I'm looking forward to your feedback. Would be nice to like tell me either today or tomorrow, or send an email so that I could provide the doodle with all possible options, like all the combinations that might be interesting for you. Any other exam that you think might be problematic for this kind of planning? So it would be nice to plan ahead, so we could get this done in 2 weeks and know that, okay, this is the actual calendar we are gonna follow. I'll just check. Oh, okay, streaming is good now. Okay, if you have no further comment, then I will start with the lecture, with the actual lecture. I will see whether we have time for covering all the stuff, but yeah, let's start then. See, so does anyone remember what was rasterization? Any comment?
I remember.
Yeah?
It's turning the 3D model object and rasterizing into a 2D, so we can have it on our screen.
Yeah, exactly. So actually converting it into the pixels that have particular colors. But we have just like triangles, we have vertices, and we convert it into the pixels. And so far, like the simplest way that was assumed, or maybe explicitly mentioned, was that how to handle the pixels in between the two vertices. Because we have a vertex shader, but we don't have explicit definition for the color of the pixels that are between the vertices. So one of the simplest way was linearly interpolating that, so taking like two vertices and calculating the color value based on the distance to those vertices with some like particular weights closer to the vertex, larger the weight of that. So I think linear interpolation is familiar for all of you. But in reality, this wouldn't really work for sophisticated tasks because the surfaces are very complex. Like if you have grading, for example, if you have the vertex that is black and white and you have the gradient of gray, okay, that can be very simple representation, but how would you represent something very complex, like maybe this wood or human skin, or I don't know, the image of that forest. So usually in real life, and especially if we want to have photorealistic representation, the structure is super complicated to and super computationally costly to calculate this way. So yeah, the way can be have a very high number of vertices and calculate colors for those vertices for all tiny points to have like very tiny triangles and corresponding vertices. In that case, that gradient won't be that homogeneous. There will be more details, but it will be super costly computationally. So one of the workarounds for this problem can be texture mapping. So texture mapping is simply without adding new vertices, just to take an image and to put on our object to make it look realistic. And we will have color for all points or corresponding points that come from this texture, and we don't need to interpolate between the vertices in this case. And we have like higher resolution and details. For example, in this case, imagine if you had to represent all the details by corresponding vertices, how running a shader to calculate the color for all the vertices. That would have been like super costly and complicated. So this makes our life very easy because you can simply take this texture and put on your object, or take this grass texture and put on your object and make it look like a grass or wood. So texture details. Textures can be either one-dimensional, that is relatively rare, or three-dimensional, that can be also possible, but the most popular one are 2D texture maps. When we have this texture and we find correspondences between the texture coordinate or texture element and the object point, and we map them to have particular texture component moved on and located on the object. And it can be an image like this Coca-Cola sticker, or it can be actually procedural approach. The texture does not necessarily imply having some image, for example, some paper, and putting it on. Well, this is one option. You have the texture and you put on the object and you project this visualization onto your object. But that's not the only way of doing that. You can have that defined mathematically. For instance, oh yeah, by the way, have a look at this video, because if you want to go deeper into the math, this is super informative. It has two parts. This is the first part, and then you will find the second part as well. So it explains all the math into the depth and all like more fundamental stuff that we can't cover within the scope of this course, because right now I just want to explain basic principles and ideas, but for like better understanding, refer to that one. It's very good video, very clear, very easy to understand. Yeah, for example, procedural approach, what does it mean? We have some function, we put coordinates of the object point, for example 2D point or 3D point, and we put that into the function, and we have some color calculated based on the function. For example, super simple one, we have function myTexture. We put x, y, and z coordinates of this 3D object placed within this x, y, z space. And what this function do is that we just check whether, in this case, we vary only across x-axis. So we just don't care about y and z. So we put sign of that number, we have the coordinate, and sinusoidal is going from -1 to +1, right? And this is a wave. and we can have values either above 1, above 0, or below 0. And this checks whether the value is above 0 or below 0 or equal to 0. And if it's above 0, it returns 255. If it's in red, and 0 and 0 in two other channels, so it returns poor red color, red primary. And if we have sign of this one below 0, it returns white. So it returns different color. And if you have like this kind of wave, you can have a look like when the coordinate changes. So we don't care about x and y in this case. When the coordinate changes, we have red, then sign became below 0, it became white. Sign went above 0, it's red again. It's below 0, white again. So we have this wave actually somehow projected on this one. And we define these stripes like red, white, red, white, red, white. Likewise, you can do that for other x's as well, like in y dimension. If you do the same for, if you put y here instead of x, you can have stripes in this direction. No, sorry, this for z, in this direction. And for y, you can have these stripes in this direction. And of course, you can, this is just like simple example, you can have any implementation, any way to mathematically define your structure, whatever you want to be your texture. You can use like true coordinates to have something like checkerboard, or like anything you can imagine mathematically describing your texture. So is this approach clear? So you got how it works, right? You put coordinates into the function, and based on something you want to have, it calculates corresponding colors. But even using this one, it's not possible. It's possible, of course, but it's not feasible to represent very, very complicated and sophisticated textures. And that's why we have need for actual 2D images. Because, for example, representing this one mathematically would be very, very tough and very challenging, because we have some amount of randomness here. It's not very, even though it looks repetitive, like natural wood has some degree of randomness, so it will be difficult. Well, texture mapping is like process of mapping between the texture elements and object pixels, but it can be like perceived the other way around as well. You can like either think of taking a pixel in the object, like point, and place it on the texture space, or you can think the other way around, folding or wrapping your object into the texture, so putting the textures on your object. So both ways make sense. Like, for example, here is an example. We have this cylinder, we have some texture, and we just like put that texture on this one and it gets the texture. But there are like some techniques. One of the technique is unwrapping. So what unwrapping is that we just wrapping is like, for example, when you want to wrap your present, you have wrapping paper and you put the paper on your object. Like in this case, for example, I have this phone and I just wrap inside this texture. Imagine this is texture, but unwrapping is opposite to that. So I have the texture and I want to unwrap my object and place it on the texture. So when we have 3D object, we cut these tiny triangles in a way to place it in a single plane. But the challenging point is to decide where to cut, like how to cut our 3D object to place it into a plane, in two-dimensional plane. So if I had some object like this, then I have to decide where to cut and how to put it so that it looked like this. And yeah, here is a example of correlation between the 3D object and the map. So the texture texture map can be thought of as a map, a map of the world, for example. This can be a texture. And the 3D object that your model you want to place your texture on, imagine as a globe, and your task is to put this texture onto a 3D object. So it can be either you can either project this on this one, or you can unwrap this, so cut this one in a way that it's put on this texture in a logical way. And some basic terminology. Topology just says us what is the structure of those elements composing the model. Like it has information about connections, but it doesn't have information about actual shape and allocation in the space and how far they are. So it says like what is connected to what. But geometry, on the contrary, has this spatial and location information. For example, those two parts, let's say, can be connected to each other. That's topological information. If I tear this paper and put them on different locations, the topology changes. But if I have them together and just move them, then yeah, then topology is the same, but the shape and distance between them changes, so the geometry changes. And yeah, if we flatten it, if we unwrap it, it becomes equivalent to a flat disk. If we just put them into a single 2D plane, for example, when we here cut the animal and put its skin onto the 2D, or for example, if you try to tear your ball and flatten and put it also like across this table, and yeah, it becomes a disk. Here is a good example of that. So if we move these vertices, if we just move these vertices, but each triangle remains connected with the same triangles, then we change the geometry, but we keep the topology. But if we rearrange these triangles to get something like this, for instance, then we don't have the same topology, neither the geometry. So this was, unwrapping was one approach. Another approach, so functional mapping is like the procedural approach that I have actually described here. And Atlas is imagine like a kinda lookup table. For unfolding purposes, it's important where texture elements are located. So Africa should be like this, so you can put this one and take here, and put this one and take here, because then the texture will change. But Atlas has just like some independent parts that you can refer to, so any triangle can go anywhere within the atlas and pick up the location. So it's not necessary to be connected. I think this is not very good visualization, so this is better explanation. So this is used for efficiency, when you don't need to keep like tens of texture maps for your object. You can have like single atlas with all kind of texture elements in it, and then you map from that one. So this is sprite sheet. Actually, it's similar to what I have shown today about Pac-Man and Gauss. Like I will get back to you just to make sure, because I don't want this to be something just theory. I just want you to see how this is used in practice. So this can be taken as a texture atlas. In this case, you take this Pac-Man and project it on the Pac-Man object, and you take this, refer to this part of the atlas and project on the Ghost. That's it. So it's actually literally the atlas where you have possible textures and where you just try to find it and match to the corresponding part of your scene. Yeah, projection. How do we project? So how do we put this 2D onto the 3D, or the other way around, matters a lot and can make huge difference. For example, if we take map and globe, So we have Earth that is kind of spherical shape, not perfect, but still spherical. I hope everyone agrees. Any flat earthers? Thank you. Yeah, so like, yeah, we have like several ways of putting sphere onto the 2D and several approaches, and visually they differ a lot. Like it can be done one way or the other way or another way or this way or this way, or there are like lots of different combinations. The key idea is that if you the key idea is that the surface of the sphere is projected onto this one, so from this one you can recompose your sphere, but that's not always perfect, so there is no one-to-one correspondence between the sphere points and map 2D points. That's why we don't have one unique and best projection for creating the maps. So all of them come with their advantages and disadvantages. You can have a look like other options and ways how different projection can make the result look. So projection is just, as I said, mapping from 2D to 3D, and some interesting, yeah, and we have this function where we put x, y, z, and we come up with coordinates onto the texture space. If we get back to here, yeah, here we take the 3D coordinate on the surface of the sphere, x, y, z, and some function tells us where should it be placed on the texture and where is u and v coordinates on the 2D texture. Yeah, and there are some different ways of projecting. For example, flat or planar. I would like to describe them more in details on the next slides. So when you have just like one plane and you put project in the way it is just from one direction, you have spherical when you have like, oh, we don't have spherical here, yeah, I'll show you. When you project your texture in like a sphere around your object, cylindrical, like for example, lots of maps like Mercator projection, for example, this one is a cylindrical projection, example of cylindrical projection. So how it works is that you have your object and you wrap your texture map around the object like a cylinder, and you then find correspondences, and like higher you go close to the pole, this angle increases. Like we have, if you have a look here, like this distance increases, and that's why we have Greenland usually and Antarctica like look so ugly and unrealistic. Yeah.
Good, perhaps to take a break there.
Oh, sorry, yeah. Okay, maybe I will finish this projections part. I have 2 more slides, and maybe then in 5-6 minutes, if it's not too urgent, because to finish the topic and then...
I'm getting a drive.
Okay, okay then.
And wait a little bit, yeah.
Okay, okay, let's have a break then. Okay, let's have it now.